Yes. Am I audible?
Yes, Sanskruti.
Yeah, let me start. So, good evening to one and all present here. Myself, Sanskruti Mishra, and my co-intern Sakshi Panwar. Today, we are here to present a session on pre-training a large language model. So, do sit back and look at the presentation, and then try to understand what we're trying to say. So, let's get started.
So, hi everyone. My name is Sakshi. We are starting from what are the large language models. So, we explain that these models are trained on vast amount of textual data without specific knowledge of downstream tasks. The process involves two main steps. First is pre-training. Second is fine-tuning. So, first is pre-training, where the model are exposed to vast amount of text data. They learn the statistical patterns, structures, and semantics of language without being trained on specific tasks. So next one is fine-tuning. So once pre-trained, LLMs can be fine-tuned on specific tasks refining label data and adjusting their parameters to optimize. We can see first is the unlabeled data. So what is unlabeled data? This is the raw data that does not have any corresponding labels or categories associated with it. It can be any type of data such as text, images, or audios, depending on the problem you are trying to solve. Second is untrained model. This is the basic learning or deep learning model with no weight or parameter initialized. The model need to learn from data to make accurate prediction. Then third is task specific data. This is the label data required for training the models. It consists of input data along with the corresponding output or target label that the model should predict. Then input in that context, input refer to the data being fed into the model during the training or fine tuning process. Now pre-trained model. What is pre-trained model? This is the model that was already been trained on the large dataset. It has learned features, patterns, and weights that can be used for other similar tasks. So, fine-tuned models, this is the model that has been initially trained on a large dataset and then further fine-tuned on a smaller task-specific dataset. By doing this, the model can adapt to new tasks with fewer training example and achieves better performance. And after that, these fine-tuned model, we are coming to the output. So output, this is the result of the model prediction on the input data. It can be classification data, a regression value, or any other type of output depending on the problems. So next one is in general there three types of sequence labeling. And next one is unsupervised learning. Unsupervised learning involves training the model label data.
Yeah, sorry to interrupt, Sakshi. Your voice is breaking. Can you check?
Data. The model is trained to predict certain aspect of the input data efficiently, creating its own supervision signal. This allows us gain properly in area where label data. There are two main reasons that we can use LLMs, instead of building a ML models, use from scratch for many tasks in NLP. First is data availability. LLMs benefits from the evidence of textual data available on the internet. Pre-trained large dataset help LLMs capture diverse linguistic patterns and notions, leading to improved performance or downstream tests. Second is scalability. LLMs is highly scalable, capable of handling vast amount of data and complex tasks efficiently. Their achievements and coupled with advancement in hardware and distributed computing enables training and inference scalable. And after that, we are seeing the task examples of where we are using LLMs. First is machine translation, NER, machine reading
Sakshi, your
comparison,
voice is breaking.
sentiment analysis, summarization. So, what is machine translation? This task involves translating text from one language to another. LLMs has shown impressive performance in machine translation by learning to understand and generate translation that present the meaning and context of the original text. Then second one is NER, name entity recognition. Name entity recognition is the process of identifying and classifying name entities without text, such as people, organizations, location, dates, and more. LLMs can accurately identify and clarify name entities, which is useful for various applications like information extraction, question answerings, and document categorizations. Next one is the machine reading comparison. In this task, LLM are required to understand a given passage to text and answer question based on the information contained with the passage. LLMs has strong performance in machine reading comparison tasks, such as human level performance on certain benchmarks. Then last second one is sentiment analysis. Sentiment analysis involve determining the sentiment or opinion expressed in a piece of text, whether it's positive, negative, or neutral. LLMs can analyze large volume of text data to identify and clarify sentiments accurately, enabling applications like social media monitoring, customer feedback analysis, and brand sentiment analysis. Then last one is summarization. Summarization is the process of the generating concise summaries of longer text while preserving key information and meaning. LLMs can efficiently distill the main points of documents or articles, making them invaluable tools for tasks such as document summarization, news summarization, and content generation. So now next one is the key steps.
Talking about the key steps, so essentially there are 4 steps that is crucial for pre-training a large language model, with some nuances that is specific to the context. Let us first start with data curation for LLM. So data curation essentially focuses on massive amount of text data. So LLMs will always require huge amount of diverse text data in order to learn the intricacies of the language. This can be books, articles, code, web crawl data, and more. Also, we always prefer the quality over quantity. While the data size is important, the quality significantly depends on the LLM's performance. So if we filter out the irrelevant, misleading, biased content, it will make the LLM more stronger than ever. Moving ahead, there's balancing of diversity and relevance. To ensure that the data encompasses various types of writing styles, domains, and topics, it also aims for relevant data to downstream the task of LLM to be fine-tuned for. The next process to briefly explain, there are model architectures for LLM. There are transformer-based models. LLM often leverage the power of transformers, a deep learning approach specifically designed for handling the sequential data like text. So also model architecture will specifically require pre-training objectives because it is tailored to pre-training objectives such as predicting the next word in a sequence or reconstructing the parameterized mask sequence. Next, also we talk about the parameter efficiency. As the LLM require a large amount of data, the computational resources are essential for the researchers to focus on developing the parameter efficient architecture for beta scalability. When we talk about the training scale for LLM, it usually talks about distributed training. So we have to split the training across multiple machines or GPUs to understand the nuances of massive data sets that is used for pre-training objectives. Next, also the most important task is to use efficient optimization algorithms like Adam, which is used to efficiently update the model parameter during training. Also, hardware acceleration, utilizing specialized hardware like GPUs and TPUs significantly accelerate the training process. Evaluation. The evaluation of LLM evaluating the model ability to perform the pre-training objectives like perplexity for the mass language modeling, and also assessing on the downstream task after fine-tuning on specific data set showcases its ability to learn the generalized knowledge. Moving ahead, the next slide, please. We will be talking briefly about the NLP powerhouses. So NLP powerhouses, the first one is GPT-4, which is developed by OpenAI, is a large language model that uses a transformer-based architecture. It has over 1.8 trillion parameters and is trained on a diverse range of data like internet text, books, and proprietary datasets. But from Google is bidirectional encoder representation transformers. It's a transformer-based model that is pre-trained on a large corpus and is fine-tuned on a variety of tasks. Robota is a variant of BERT that uses various pre-training approach and it is found to outperform BERT in several benchmarks. T5 is also text-to-text transformer that treats every NLP task as a text generation task and was pre-trained on the large corpus of text. Next slide, please. Pre-training an LLM is a significantly challenging task. LLM infrastructure is dealing from the perspective due to two big reasons. For starters, it's simply no longer possible to fit all the model parameters in the single memory. Even the largest of NVIDIA GPUs, say NVIDIA 8GB A100, you will need some parallel architecture here and there. The other challenge is that a large number of computational operations can result in unrealistically long training hours if you are not concurrently optimizing your algorithms and your hardware stack. So training the GPT-3 with a 175B parameter would require about 288 years with a single V100 NVIDIA GPU. So there are several strategies that can be used to accumulate this task. That's why we talk about parallelization. Next one, please. Parallelization refers to splitting up of a task and distributing them across multiple processors or devices such as GPUs so that they can be transformed and trained simultaneously. This allows more efficient use of computational resources and faster completion times in comparison to training it over a single processor. Parallelization training is an effective way to reduce the overall time that is needed for the training process. And there are several methods, including gradient accumulation, micro-batching, data parallelization, tensor parallelization, pipelining, and much more. So typical LLM will employ a combination of these methods in order to train the large language model. Next slide. So if we talk about the advantages of parallelization, the first one being faster training. So when we're distributing the workload across multiple devices such as GPUs or TPUs, the parallelization significantly reduces the training time. So I can summarize this by saying, imagine multiple chefs working on a part of a complex dish simultaneously, signifying significantly speeding up the preparation time as compared to a single chef doing everything alone. Next, talking about scalability, parallelization allows researchers to handle the ever-growing datasets and more complex models because as the LLMs are continuing to evolve, it can trade on massive data volumes, pushing the boundaries of what's possible. Also, we can optimize the resources by utilizing the maximum available computational resources. This not only reduces our time to train an LLM, but also the resources are ensured that they are used efficiently, which leads to cost effectiveness and more sustainable approach to LLM development.
So now data collections. It is a very important part of any models. So we are discussing the critical process of data collection and dataset preprocessing. The quality of dataset significantly influence the performance of model. Diverse, high quality dataset offer several benefits. Like we have a bad data, then obviously we have a bad model. So they are the some parameters such as model performance. Quality data leads to better performing models, ensuring more accurate predictions and outputs. Efficient model convergence. High quality dataset facilitate faster convergence during model training, saving time and computational resource. And next, cross domain knowledge. Enhanced cross-domain knowledge, diverse dataset allow models to learn from various domains, expanding their understanding and adaptability across different contexts. So, better downstream generalization. Model trained on diverse dataset tends to generalize better to unseen data in downstream tasks, resulting in more robust and reliable performance. And next, they are if we take the example of valuable dataset includes the pile common crawls and dataset provided by Hugging Face, which in compress a wide range of textual data from different source and domain. Next one is dataset preprocessing. So now let's dive into the dataset preprocessing, a step in preparing data for model training in NLP. Dataset preprocessing involves several initial steps to ensure that the data is clean, standardized, and optimized for effective model learning. First is the sentence splitting, dividing into the blocks into the individual sentence for better processing and analysis. Next one is quality filtering, removing low quality text to maintain dataset reliability, ensuring that only relevant and accurate data is used for training. Next one is character removal, eliminating non-literal characters such as marks not used in language which may interface with model learning and prediction. Last one is white space and foreign elements normalization, standardizing white space and removing character from other language, ensuring consistency and compatibility across different data sets. And next is non-textual content removal. So, what is non-textual content removal? Eliminating emotions, symbols, and other non-textual elements for focusing solely on textual data relevant to tasks at hand. Privacy reduction, removal personal information and relevant element using regular expression to ensure data privacy and complies with regulation. Last one is data deduplication, eliminating data from web scrap corpora to enhance training efficiency and prevent bias in model learning. Next one is tokenization. So tokenize is the process of converting text into the numerical representation tokens, which is initial for modeling in NLP. So in NLP, most large language models use subwords tokenized like byte pair encoding (BPE) to handle rare words and out of vocabulary term efficiently, ensuring comparison convergence of the vocabulary. And tokenization play a crucial role in a representing task for model training and contributing significantly to the overall performance of NLP models. And next one, this is a diagram. This is a diagram of, in this diagram we see first is model. So choose the model. Roughly speaking, language model can be grouped into the two main classes. Like first is the representation. Representation models are more suitable for classification tasks such as NER, and generation model are more suitable for generation tasks such as translation. And then after the model we are going to the corpora. So prepare the pre-trained corpus to prepare and share data for different use. And after the corpus we are going to the tokenizer. So train the tokenizer of once the model is chosen, and Pre-trained corpus is prepared, so one may also want to train the tokenization and on that pre-trained corpora for scratch. And after the tokenizer, we are going to the pre-train and pre-train the model. Hugging Face Transformer also provide convenient wrapper for training deep neural network. And in the pre-train we are seeing first is data collector. So data collector, there are many predefined data collector that can meet the requirement of different models and pre-trained task. And the second one is training and trainer. So with the convenient wrapper for training loop, one can simply specify hyperparameter and training in the past them. After that, last one is sequence to sequence trainer. So sequence to sequence trainer, similar wrapper as above sequence to sequence models. After this pre-training, we are going to the fine tuning the model depending on the use case. Ones can now fine tune the pre-trained model for different downstream tasks. First, prepare the data. Dataset can be used to prepare and share data. And next, train. The model learns from the pre-training data. Evaluate. The model performance is assessed on the validation set. And now, and the end, fine tune the model. Pre-train model is further trained on a similar task-specific data set to adapt to new tasks and improve performance.
Now I'll be talking about the model architecture choices. So typically the pre-trained model is evaluated on various ways. So we are going to talk about transformers. So transformers are the neural networks that work on attention mechanisms. So what is attention mechanism? Unlike the traditional recurrent neural network, transformer rely basically on attention mechanism that allow them to focus on specific parts of input sequences information. This is crucial for LLM as they need to understand the relationship between the words, that is across long distances within a sentence or even through multiple domains. This will allow parallel processing. So transformers are inherently parallelizable, meaning that different parts of the model can be computed simultaneously. This is particularly beneficial for a distributed training across multiple devices, as I discussed earlier, which is essential need for handling vast amount of data. So efficiency, the transformers can also achieve higher accuracy patterns as compared to other architectures like LSTM. While the basic transformer architecture will form the foundation, various specialized variants for LLM pre-training and fine-tuning is also developed like BERT, GPT-3, XLNet. Moving on to the next slide. The encoder-decoder model, as originally proposed, the transformer model consists of two stacks. One is an encoder, another one is a decoder. The encoder is fed on the sequence of input tokens and it outputs a sequence of vectors of the same length as the input. Then the decoder regressively predicts a target sequence token by token, conditioned on the output of the encoder. The representative models of this type include T5 and BART. Moving on. Typically, the pre-trained models are evaluated on a diverse language model datasets to assess their ability to perform, logically reason, translate, natural language inference, and question answering, and much more. So, the first thing that it works across is benchmark datasets. So, benchmark dataset provide a standardized platform that will provide the platform for comparing different LLMs. This will allow the researchers to develop and track several progress in the field and identify areas where advancement is needed. This would also contribute towards reproducibility. Utilizing standardized datasets ensure that the reproducibility of evaluation results will enable the researchers to compare the findings and build upon each other's work seamlessly. So, some prominent benchmark data sets that exist for LLM evaluation is GLUE, General Language Understanding Evaluation, and SQUAD, Stanford Question Answering Dataset. Apart from that, the Hugging Face leaderboard also serves as a wonderful medium for model evaluation that tracks and ranks open large language models and chatbots. These include the Chatbot Arena, MTBench, MMLU, which is a 5-shot language evaluation benchmark. Also, there is a way to submit your own model for evaluation. Next, we'll be talking about the multiple choice task. Multiple choice tasks will support efficiency because it's an efficient way to assess the LLM performance to various tasks. They allow for automated evaluation. It saves time as compared to the standard manual evaluation methods. Similar to benchmark dataset, the multiple choice tasks also provide a standardized format for evaluation, which facilitates the comparison through various LLMs and studies. Next is the open-ended task. Open-ended tasks go beyond the constraints of multiple choice formats, thus allowing a deeper exploration of LLM capabilities. They are able to assess the model's performance to perform creative tasks like generating different creative text formats, summarizing the complex information, and engaging in open-ended dialogue. It also gives real-world relevance because they resemble real-world scenarios, providing a more comprehensive understanding on how LLM will work in practical applications. However, there are several challenges. Evaluating open-ended tasks can be subjective and challenging as there might not be a single correct answer. Manually, evaluating such tasks can be consuming and resource intensive. However, a combination of methods are often used to paint a holistic picture of the model's capabilities. Human evaluation involves humans in evaluation process because humans can provide valuable insights like the model's coherence, factuality, and fairness, which might not be captured through automated process. Next slide, please. In the next here, we are going to discuss about the fine tuning. Instruction fine-tuning is a powerful technique that is used by the large language model to perform the specific task. The core idea behind it is that a pre-trained model is served as a foundation. So instruction tuning leverages a pre-trained form that has already learned from a vast amount of general knowledge upon which the language is developed. The pre-trained model acts as a strong foundation on which the task-specific knowledge can be built. Then we are going to add specific task and instruction. Instead of simply training the LLM on data, instruction tuning incorporates instructions that guides the model towards a desired outcome. Next, there are two formats by which these instructions can be fed in: by prompt-based instruction and reinforcement learning. Prompt-based instruction explicitly states a desired task, provide the examples or guidelines in the form of prompts. The other one, reinforcement learning, learns through trial and error, where the application receives rewards for completing the task correctly according to the provided instructions. The benefits of this is it will improve the performance because it will significantly improve performance on particular task as compared to traditional fine-tuning with just additional data. This can also be applied to various tasks because this will enhance the versatility of the LLM. Question answering in specific domains. LLMs can be fine-tuned to answer specific questions within specific domains like legal or medical framework, utilizing the domain-specific knowledge and terminologies effectively. Text generation tailored to specific style of formats. Here, the LLMs can be instructed to generate creative text formats like poems or scripts and adhere to specific writing styles like formal, informal, or vernacular. Code generation with precise requirements. LLMs can also be used to generate code that meets specific functionalities and adheres to the best coding practices. Current advancement is that it is still an active research area. Instruction tuning is a rapidly evolved field with researchers exploring various instruction formats and training methods. More challenges that is evolved during this process is the model cannot simply memorize the instruction but truly generates true unseen data remains an ongoing challenge. Moving ahead, we will talk about the train or loss curves. The train or loss curves is the entire training process involves a train or loss curve. The curve is not specific to a single step, but it reflects the entire model's learning throughout pre-training. The training loss indicates how well the model performs when the data is continuously fed during the pre-training. Ideally, the training loss should decrease over time as the model is able to learn and better to predict the desired outcomes on the pre-training objective, like predicting the next word in a sequence. A consistently high training loss suggests that the model might not be learning effectively. Next, when we talk about the validation loss, this measures the performance on a separate validation set that is not used on training. It is crucial to prevent overfitting, a phenomenon where the model simply memorizes the training data and fails to generalize the unseen data. So ideally, the validation loss should decrease over time or at least remain stable over time. So here in blue, we can see the validation curve, and in red, it is the training loss curve. So here, a significant increase in the validation loss indicates overfitting or necessitating adjustments to the training process. So moving ahead, the this one the LLM pre-training is an extremely resource intensive process because it plays a pivotal role in NLP task is a foundational subject, but it is highly resource intensive because it requires massive computation time, the GPUs for uh, parallel processing, then the cloud platforms for scalability, hundreds and thousands of devices for large models. It also consists of a large data because billions and trillions of word is required through diverse resources, and careful curation for pre-processing is required. An expert team of machine learning experts, computational specialists are also required. Moving ahead, it also costs millions of dollars for cloud personal experience, and it also renders an accessibility challenge because many large companies and resource institution and they also smaller teams face several barriers. Future look is optimization and efficiency. Here we need to improve the resource utilization, and efficient training techniques are to be utilized like mixed or precision, also hardware enhancement. Here we have sparse attention, custom accelerators, lower burden. In conclusion, that LLM pre-training essential but demanding. So collaboration and innovation will drive progress. So it is essential to democratize the access and shape the future. Moving ahead.
So now we are going to explore some of the current LLMs, and these models represent the forefront of research and innovation in NLP. So first is Claude. The Claude LLM focus on constitutional AI with shape AI output guided by a set of principles that help the AI assistant it power helpful, harmless, and accurate. Cloudy was created by the company Anthropic and powers into two main product offering, Cloudy Instant and Cloudy 2. Cloudy 2 excels at complex reasoning according to Anthropics. Now, second was is Cohere. Cohere is an enterprise LLM that can be custom trained and fine tuning to a specific company's use case. The company that created the Cohere LLM was founded by one of the author of Attention is All You Need. One of the Cohere's strength is that is not tied to one single cloud, unlike OpenAI, which is bound to Microsoft Azure. Next one is ChatGPT. GPT-3 is OpenAI large language model with more than 175 billion parameters. Released in 2020, GPT-3 use a decoder-only transformer architecture. In September 2022, Microsoft announced it had exclusive use of GPT-3's underlying model. GPT-3 is 10 times larger than its predecessor. GPT-3's training data, including Common Crawls, Web Text 2, Books 1, Books 2, and Wikipedia. GPT-3 is the last of the GPT series of the model in which OpenAI made the parameter counts publicly available. And next one is GPT-4. GPT-4 is the largest model OpenAI GPT series released in 2023. Like the other, it is the transformer-based model. Unlike the others, its parameter count has not been released to the public. Though there are the rumors that the model has been more than 170 trillion. OpenAI described GPT-4 as a multimodal model, meaning it can process and generate both language and image as opposed to being limited to the only language. GPT-4 also introduced a system message which lets users specify ton of voice and task. GPT-4 demonstrated human level performance in multiple academic exams at the model's release. Some that GPT-4 come close to artificial journal intelligent. It is also called a AGI, which means it is as smart or smarter than a human. And next one is Llama. Llama, Llama is large language model Meta AI. Is a Meta LLMs released in 2023. The largest version is 65 billion parameters in size. Llama was originally released to approved researchers and developers but is now open source. Llama come in smaller size that require less computing power to use, test, and experiment with. Llama used a transformer architecture and was trained on a variety of public data sources, including web pages from Common Curl, GitHub, Wikipedia, and Project Gutenberg. And next one is the Lambda. Lambda is language model for dialogue applications. So Lambda is a family of LLMs developed by Google Brain, announced in 2021. Lambda uses a decoder only transformer language model and was pre-trained on a large corpus of text. In 2022, Lambda gained widespread attention when the Google engineer Blake Lemoine went public with claim that the program was sentient. It was built on sequence to sequence architecture. And after that, we are going to the conclusion. So, Sanskruti.
As we conclude our discussion on pre-training of large language models, let us recap the key takeaway. First thing is that the pre-training will serve as a bedrock for natural language understanding and generation. LLMs that is powered by the architectures like Transformer have revolutionized the field. Next, the architecture choice always matters. The choice of architecture simply impacts on the model's performance. The transformers with attention mechanism enables the context-aware representation. Hyperparameter tuning is also essential for optimal results. Evaluation metrics to gauge the LLM effectiveness, we rely on metrics such as perplexity, F1 score, task-specific measures. These guide the model development and fine-tuning. Also, it provides a dynamic landscape. Language tasks are ever-evolving process. Continuous exploration, adaptation, and model refinement are often crucial. Researchers and developers play a pivotal role in shaping the futures of LLM. Community collaboration. We should always encourage the collaboration, knowledge sharing, and innovation. Together, we can unlock new frontiers in language understanding and communication. Thank you all for sitting back and joining us today. Do keep exploring, keep creating, and pushing the boundaries of LLM models. Thank you.
So, thank you so much.
Yeah, thank you. Thank you, Sanskruti and Sakshi. Yeah, maybe we can stop the recording and we can take few questions. So the devices maybe can stop the recording, and yeah, maybe if somebody has some questions, we can take few questions. So yeah, anyone have any question for Sakshi or Sanskruti?
I have a one suggestion.
Yeah.
Yes, ma'am. Yes,
If
ma'am. Please.
if you put that all the LLM models in a table, and you will write the strength or the features of different models.
Okay, ma'am.
Okay, then it will look good. I mean, because the like simple lines will be explaining more than that you have written in the text form. Na? If you put in a table form, then you should write like what are the important features are there, or how many number of collections of data set column would be there, or the feature they have used, or which algorithm they have used, whatever. So you can include in the table form also.
Okay, ma'am. Next time we are going on.
Okay.
Okay, thanks. Anybody has any other question for Sakshi or Sanskruti? Someone. Yeah, it seems no question, but yeah, some comments about the presentation. Yeah, I think presentation was good, but there was like some disturbance in the beginning. So my voice was breaking, maybe due to poor internet connection. But anyway, overall it's good. So thanks to both Sakshi and Sanskruti, and to all like who have joined the session. And we'll plan the next session, I think, for hands-on. So and for other topics. So feel free to join. So we'll announce like when the next session is there. So till then, yeah, we can stay in touch. And yeah, if anything is there, we can discuss more in chat, because I think already all we are in the group, so we can discuss more. So yeah, that's all. So thanks. So we can maybe we can end the session here.
Thank you.